right, tomorrow you're taking your very first district exam. It's a final, so you may not retake it. So I just want to make sure you guys are okay with Pythagorean's theorem, and because there's going to be a lot of that on your exam, Pythagorean's theorem, as well as the proof that I'm expecting you to do. So Pythagorean's theorem, when I say Pythagorean's theorem, we use that to find the length or the distance of lines, and people typically associate it with a squared plus b squared equals c squared. But if I don't tell you what a, b, and c are, it doesn't really mean anything. So when I say a squared plus b squared equals c squared, the a and the b, I'm talking about the legs of the right triangle. Legs are the ones that touch that right angle. We have to be talking about a right triangle for Pythagorean's theorem. The c, when I say c, I'm really talking about the hypotenuse. The hypotenuse is the longest side of a right triangle, and it is always across from the 90 degrees. So the c is considered the hypotenuse. If I give you a question tomorrow on your final, and I want you to find the distance of this from this point to this point, I'd have to give you some information, like right angles. Okay, so I have some right angles. Now that I know this is a right triangle and I know this is a right triangle, and we'll talk about in chapter 6 why you can say that this is a rectangle or a square. Okay, so we're getting closer. There's some more information I have to give you. I have to give you some sides of the triangle, right, in order for you to find this missing side. What you're going to do is you're going to look at one triangle at a time. Look at one polygon at a time. So let's say this is 20. Do you have enough information to find out what this side of the triangle is? Of course not. I have to give you more information. I have to tell you what this side is. So let's say I tell you this side is 12. Now can we use Pythagorean's theorem to figure out what this side is? Well, let's see. We have 20 as the hypotenuse, so I can say 20 squared equals, and then I have to add up these sides. And this doesn't matter which one's your A and your B. The legs, the order of the legs do not matter. So I'll call this A just for good measure. So A squared plus 12 squared. So I have A squared plus my B squared equals my C squared. And then I'm going to solve. 20 times 20 is 400. A squared, and 12 times 12 is 144. Now to get my variable by itself, to isolate my variable, I'm going to have to subtract 144 from both sides, and then I'm going to have 256 equals a squared, and to get rid of this exponent, you're going to have to square root. So I have that this side of the triangle is going to be 16. Okay, so you can do that again. Let's say here these sides are congruent to each other, and these sides are congruent to each other. So I want you to try Pythagorean's theorem. Practice for a second. You know this side's going to be 12. I'm going to give you a different number. Let's say I give you 25. Go ahead and figure out how long this part of the triangle is, and we'll call this B so we don't get confused. Okay. Once you have your B, you're going to add up what we have with it, so plus 16, and then I have to tell you how long these sides are, and it'll be given to you. Let's say it's 10, so you're going to add up this part, 10, and that's going to be your final answer. So one more time. To find the length of this yellow line, you're going to first do Pythagorean's theorem on this triangle to get 16. Then you're going to do Pythagorean's theorem on this triangle and get whatever B is. I don't know what B is. That's what you'll have to figure out. Then you're going to add in this middle part, and this will be given to you. You cannot use Pythagorean's theorem for a square right now. I'll teach you later on in geometry how to use polygons and trigonometry and Pythagorean's theorem to use it on different figures, but right now we're just going to stick to our right triangles, and then I'll show you how to investigate further on in the year. Okay, hopefully that made sense. So again, you'd add up those three pieces, and that'll be how long this whole thing is. And I went color happy, sorry. We just wanted to find out what the yellow part was. Okay, the next thing you're gonna have to do is your proof. The proof, I'm gonna give you, you know, some lines and some angles like this, and I'm gonna ask you to solve and justify each angle. So let's call this angle 1, 2, 3, 4, 5, and I want you to justify your answer. So let's say this angle is this kind of looks obtuse to me. I'll say it's 105 degrees. Okay, and this is all that I'm giving you, and I want you to not only tell me what all the angles are, but justify your answer in a proof form. So we could start off with a given that angle 3 equals 105 degrees. That's given. Some people are also going to want to say that angle 5 equals 90 degrees as given, because that's what it looks like in the picture. That's true, but technically it says angle 5 is a right angle. And that would be your given. And then you could say, because it's a right angle and because that's what the word means, because that's the definition of a right angle, angle 5 equals 90 degrees. I won't mark you off, but I want you to get better at using your definitions and specifying it just a little bit more clearer. Okay, clearly, excuse me. Okay, so we have 1, 2, and 3. Sweet. We have already named 2 angles, so we just have 3 more and then we're done with this proof. Okay, so this one's 90. Sweet. Well, what else can I do? I'm kind of stuck now, but I'm sure you guys can do the math. But again, I want you to be able to justify. And there's lots of ways you can solve this. I'm going to look at linear pair because I think linear pairs are kind of awesome. I'm going to use linear pairs. And I know that angle 3 and angle 4 are adjacent angles that add up to be a straight line. That's called a linear pair. And because they add up to be a straight line, they are supplementary.
Ricardo Rojo, please come to the office. Ricardo Rojo, please come to the office.
Okay, so that's my 4th step. I'm using linear pair theorem to say that those angles are supplementary. And then if somebody asked you what does supplementary mean, what's the definition of a supplementary, you would say that that's two angles that add up to be 180 degrees. That says angle 4 equals 180 degrees. Sweet. Now I can use substitution, and I could substitute out, kill off angle 3, and then use subtraction. Oh, sorry, I'm getting ahead of myself. Substitution. That's step 6. And then I can subtract 105 from both sides. That's called subtraction Po. And then I can find my answer. Measure of angle 4 now equals, what, 85 degrees? No, just kidding, 75 degrees. Because 180 minus 105 is 75 degrees. Okay, so now I have another angle down. Sweet. All right, so this one we said was 75 degrees. The next thing I could look at in my picture is vertical angles, right? You guys know how much I love vertical angles. So I'm going to use vertical angles, and vertical angles technically, vertical angles says that angles are congruent. So I would have to say angle 4 is congruent to angle 2. And then I have equal signs everywhere else. I want to change this to an equal sign. To change it to an equal sign, then I would have to use the definition of congruency. This is a lot of stuff that we learned in chapter 2. Since I already know what angle 4 is, right? Angle 4 is 75 degrees. I can substitute that into this equation, kill off that character, and I can say measure of angle 2 equals 75 degrees, or 75 degrees equals measure of angle 2 by substitution. Substitution. Okay, I'm almost done. I have one more angle that I need to solve for, and I'm so glad you guys stayed for the end of the video, because this is the part where most people are going to forget about. Some people are like, how do I know about everything. How do I figure out this last angle? We can't use linear pair because a linear pair talks about 2 angles.
Ricardo Rojo, please come to the office.
We can't.
Ricardo Rojo, please come to the office.
Thank you, Ricardo Rojo. We can't use a linear pair because we have 3 angles here, but you know that these 3 angles have to add up to be 180 degrees. We can't use linear pair. We can't use supplementary because the definition of supplementary, we talked about it already, definition of supplementary is 2 angles. So what we're going to use instead is all the way back from chapter 1, angle addition postulate. We're going to use angle addition postulate. This is one way you could solve this problem. And I could say that this angle plus this angle plus this angle, this is angle 1, this is angle 2, this is angle 5, are going to add up to be this straight line, which is 180 degrees. So that's what I'm going to put. Measure of angle 1 plus measure of angle 2 plus measure of angle 5 is going to equal 180 degrees by angle addition postulate. Then I'm going to say I'm going to substitute in everything that I know. So measure of angle 1, that's what I don't know, right? Measure of angle 1, I don't know. Measure of angle 2 is 75 degrees. There it is right there. And measure of angle 5, I believe that was our right angle. So plus 90 will equal 180. I can subtract from both sides. Subtraction Po. And then I'll get measure of angle 1 should equal, let me see, I don't want to do this wrong. It says 75, so that should be what, 15? 15 was 75? Yeah. So then we have our final answer. Yay! This is only one way to solve it. I want to see if you guys remember vertical angles and linear pair, definition of supplementary, angle addition postulate. This is all stuff, crucial things that we've learned, definition of right angle. These are all important things that we've learned this year so far in our first quarter, and I want to make sure you guys hit those points in our proof tomorrow. Good luck. We're going to review just a little bit before we take our dsat. Make sure you get a good night's sleep, and I'll see you